All right, guys, welcome back. We are going to be doing section 5 today, which is talking about angles. So if you remember yesterday and the day before, we did notes over segments, and then you had an assignment on segments. And now we're going to be moving into the actual angles. And so today our goals are listed here. We're going to be talking about the properties of angles. We're going to be talking about the specific types of angles. So you might have heard some of them already before. Complementary and supplementary, I think you've heard those names, but we are going to also talk about corresponding exterior, interior, and vertical angles. So let's go ahead and get started. First of all, what is an angle? Okay, so an angle consists of two different rays with the same endpoint. So let's just stop there. If you'll notice in this picture, I have a vertex at A, and if I draw up towards C, I have ray AC. I also have a second ray, ray AB. When I stick those two rays up together and I join their endpoints, that's what's creating the angle. So that's what that definition means. So the rays are the sides of the angle. And then the endpoint, of course, where they come together, we're going to call that a vertex, just like we did when we were working with polygons. All right, so whenever you look at that picture there, we can name that angle many ways. So the first way is we can name it angle BAC. So you can start with one of your points there and then go to the vertex and then come back out. So that would be angle BAC. And then of course you can go the other direction. So you can start at C and go to A and then B. So you could also say angle CAB. So both of these are the same angle, just naming them like in reverse order. Then your last option is to say angle A. So all three of these are talking about the same angle. Notice that all three of them have one thing in common. What is it? They all have an A. So the vertex is super important. The vertex is going to be the middle letter or the only letter when you're naming your angle. So BAC, CAB, or angle A. Any of those three would be sufficient. Now you'll see on our next example that you can usually name angles two ways, but this third way right here, we won't be able to use that in every case. So I'll show you why on the next one. So here's an example. It says, name the three angles in the diagram. Now, if I were to just say angle X, if I say angle X, of course, you're looking at this vertex right here, but you could be thinking many different angles. You might be thinking angle X is the big one. Okay, sure. You could also be thinking that angle X is this angle here at the top, right? And so in this case, when you see a vertex, so when you see a vertex like X that is going to several different angles, you cannot call it angle X anymore, okay? Because we would be confused which angle you're talking about. So as we name these three angles that we're asked to name, we're gonna make sure that we use the three letters to name it like we did on these two here. Okay, so let's do one of them. So let's go ahead and talk about this top angle here at the top there. So that blue angle, you could call that angle WXY. You could also name it a different way. You could call that angle YW. Oops, no, I'm sorry. YXW. Okay, so that is one angle. It says to name three. So another angle, maybe you see the bottom angle here. So that bottom angle will be angle YXZ or ZXY. So don't forget your angle symbol. I almost forgot mine. So notice that the X is in the middle, right? Because X is the vertex. All right, we need our third angle. Anyone see that angle there? Our third angle is actually the big angle. So let me get rid of that. The larger angle here, that angle we would call angle WXZ, or you could name it angle ZXW. Either one of those would make the same angle. So although we do have 6 things written right now, you're only going to need one of each of those. Okay. All right. Let's move on to the next one. I'd like for you to copy this into your notebook, or if you already printed it, that would be fine as well. But go ahead and copy this into your notebook and make sure you label all of them and make sure you write the little description below it. Okay, so I'm hoping you've heard at least of these first 3 here. An acute angle, of course, is the little small angle. So we call it like the cute angle, right? So acute just means that it's less than 90 degrees. A right angle is exactly 90 degrees, and an obtuse angle is something that is greater than 90 degrees. Now, there is something called a straight angle, which basically looks like a line, and it is 180 degrees. So let's do some examples with that. So in this example, it says to find the measure of each angle and then classify it. So what we're going to do is first figure out what the angle measurement is, and it looks like I'm missing my angles here. Okay, let me pause this and I'm going to fill these in for us and then we'll come back. Okay, so I got us a protractor on here. So hopefully that'll help us find some angles now. Okay, so we need to find the measure of angle GHK. So GHK. So you'll notice I'm just tracing out the letters. I started at G, went to H, then up to K. So from G all the way over to K, if you follow it all the way around, it looks like it stops at about 120. So I'm going to say that's 120 degrees. Now we also have to classify. What that means is it acute, right, obtuse, or straight? So we see that 120, of course, is greater than 90, and so you'll call this one obtuse. All right, let's move to the next. The measure of angle MHL. So MHL. So that's this angle here. So if you notice right here, it's at 40, and then over here we're at 90. So from here to here is how many degrees? If it goes from 40 to 90, that's going to be 50 total degrees there. So 50 degrees. And since it is less than 90, we know that that is acute. Okay, let's do the last one here. So we have angle LHK. So this angle right here in the middle. So the top part here is at 90. This one over here is at 120. From 90 to 120, how much is that? From 90 to 120 is 30 degrees. And so, of course, again, that one is acute. Okay, let's do another example. So on this one, we do have a vocab term up here. It is congruent angles. So last week we talked about congruent segments. Remember, the word congruent means they have the same length. Congruent angles means they have the same degree. So if I have 2 congruent angles, then they have the same degree measure. If one's 30, the other one's 30 degrees as well. So let's look at an example using that. It says, identify the congruent angles that are labeled in the quilt design. So if you look in the picture, we have a little swoop here, like that little, maybe I'll use a different color, this little arc looking thing, the little swoopy thing at angle G. And so that is also marked in angle A in this top picture here. So if you see those little swoops on the arcs or on the angles, that means that they are the same degree measure. So angle G is actually congruent to angle A because they have the same little swoopy thing. And then you might be thinking, well, okay, what about angle F, right? So angle F also has a little arc, but it has 2 of them, right? And so does angle D, it has 2 little arcs. That also means that angle F and angle D are congruent. So angle F is also congruent to angle D. Now, why didn't I just put like one arc on all of them, right? Well, because if I put one arc on G and one arc on A, I'm saying those are the same degree. But if I put one arc on F and D as well, you would be saying that all 4 angles were the same. So since A and G are the same and D and F are the same, but they're not all 4 the same, then we do have to differentiate using a different number of arcs. Remember last week we had a segment with a midpoint and we marked it with these little lines. Those little lines meant that those segments were congruent, right? Like from here to here was the same as from here to here. Okay, it's the same idea. If you put a little arc on an angle, then that is saying they're the same. Okay, it's the same idea as these little tick marks over here. Okay, now, let's try to answer some of these questions. It says the measure of angle ADC. So ADC is 140 degrees, 140. What is the measure of angle EFG? Okay, well, we talked about how earlier these little arcs mean that they're congruent. And so, of course, this one over here is also 140 degrees. Okay. Next, we have the angle addition postulate. So you guys are going to notice that some of these postulates that we talk about this year are like basically me taking a really easy concept and changing it into math vocab, which makes it more difficult, right? So I'm not going to read this yet up here. I'm going to ignore that. What I want you to look at is the picture over here. Okay, so I'm just going to put some numbers on there. Let's say that this one on the top is 30 degrees and this one down here is 40 degrees. So if the top one is 30 and the bottom one is 40, how much is the entire angle? How much is the big angle? Well, you would do 30 plus 40, and that would give you angle RST, right? It would give you the big angle, RST. It would be 70, right? So you already know this. Like if I have 2 little angles and they're touching, then if I add them together, I get the bigger angle, right? This is like a duh thing. Okay, so that's what they're saying in this postulate. It makes it a lot more confusing because they put all these letters in there and these symbols, okay? So let's see if we can follow it now that we already know what it's talking about. So it says, if P, so point P right here, is in the interior, if it's inside of angle RST, okay, so like you see there, then the measure of RST, so that big angle, equals the sum, remember sum means to add, of RSP plus PST. So hopefully you're thinking, yes, I already know that. I can visually see that. It is very simple to understand. But once we kind of read the postulate, it makes it a little bit weird. So basically they're just saying the big one is equal to the top angle plus that bottom angle. And we're all thinking, duh. Okay, perfect. So let's take this postulate that we just learned and we're going to apply it to an actual problem now. So here's our problem. It says, given that the measure of angle LKN, here, let me make this a little bit bigger. The measure of angle LKN. Okay, so they're talking about this entire big angle here is 145 degrees. Let me extend these out. Find the measure of angle LKM, and the measure of angle MKN. So basically, they're telling us the big angle is 145 degrees. Can you take that information and find the 2 smaller angles in between? Okay. So let's first talk about that postulate we were looking at a second ago. Remember, we said the big angle is equal to the top angle plus the bottom angle, right? Okay, so if you look in our new example, the big angle is equal to like the left angle and the right angle, okay? So the big angle, LKN, is equal to the, let's say the blue angle, because it has that blue arrow. So angle LK, oops, LKM plus angle MKN. Okay, y'all following where I'm getting this from? The blue angle is LKM, and then the red one on the right side is MKN. So basically I'm saying the big one is equal to the two smaller pieces added together. Now let's fill in some stuff that we know. We know that LKN, the big angle, is 145 degrees. We know that the smaller blue angle, LKM, is 2x plus 10. And then we know that the red angle is 4x minus 3. And so now we have a super easy algebra 1 equation that we need to solve. Let me see here. Okay, so we're going to combine our like terms, of course. 2x and 4x is 6x, and then 10 and negative 3 is 7. Okay, now we're going to subtract that 7 to the other side, and grab your calculator if you want one. 145 minus 7 is 138. And then, of course, we need to divide by 6. If you divide both sides by 6, you get x equals 23. Now, just like always, you've seen this many, many times before. This is our 5th lesson already. You know, in geometry, I am most of the time not asking for you to find x. That's algebra 1, okay? In geometry, I am most of the time going to ask you about how big is a shape? What is the area? How long is a segment? How big is an angle, right? I don't care about x, I care about the actual geometric portion now. So go back to your directions. It says, find the measure of LKM and find the measure of MKN. Okay, so I'm going to work over here on the side. LKM is equal to 2x plus 10. So I'm just getting that from the picture. However, we know that x is now 23. And so I'll just simply plug that in. So I get 46 plus 10, or 56 degrees. So I'm saying that this angle over here is 56 degrees. Okay, let's find the red angle next. If it's okay with you guys, I'm going to erase some of this down here. Okay, so now I need to find the measure of angle MKN, which is 4x minus 3, but we knew that x is 23. And so we have 90, what is that, 92 minus 3, or 89 degrees. Okay, so over here is 89 degrees. Now remember, you're going to find your two answers separately, then you're going to combine them together and see if they make sense. So grab your calculator, type in 56 plus 89. If you add them together, hopefully you're getting 145, right? Because that's how much the whole angle is supposed to be. Okay, we've got one more example and then we'll be done for the day. So your last definition is angle bisector. Now, again, we talked about a segment bisector last week. A segment bisector is when you have a segment that is cut in half. So what do you think an angle bisector is? It's an angle that's cut in half. Now, remember, when you cut something in half, you have two equal portions. So in an angle bisector, you have this angle, and when it gets cut in half, the two pieces are equal to each other. Okay, so in example 5, it says in the diagram at the right, ray YW is bisecting or cutting in half. So this guy right here is cutting the larger angle in half. In half, meaning equal. Okay, see these little red arcs, right? What do we know about that now? Those red arcs mean that they are equal. Okay, it says that the measure of angle XYW, XYW, so this top angle is 18 degrees. Find the measure of XYZ. XYZ is the larger one, the big one. Okay, if the top one is 18, hopefully you're like, okay, I know this one is 18, right? So the entire angle is how much? This big angle is, of course, the measure of angle XYZ equals 18 plus 18, which of course is 36 total degrees. So make sure you set those equal to each other. What if I had made this more complicated, right? What if I had told you that this wasn't 18? What if I told you it was 2x plus 3, right? You would remember that they are equal. So this other one is also 2x plus 3. Okay, so just remember, when I say bisect, you have two equal pieces. So set them equal to each other, and then you can solve the rest. Okay, so we are actually done for today. You do not have an assignment today. We will do the assignment tomorrow. So if you are in class tomorrow, you'll do it in class. If you are online tomorrow, of course, you'll just do this assignment and then submit it on Canvas. Okay, make sure if you have any questions that you're going to email me or that you message me on Remind so that we can get those answered. All right, guys, have a great rest of your day. See you later.